Hello friends, I welcome you to my YouTube channel MacPM. In today's video, we will solve these two numerical problems based on the projectile motion. So in our previous videos, you can go to our playlist projectile motion. We have solved many types of problems and we have derived formulas for maximum height, range, total time of flight, and equation of the projectile motion. So if you want to solve the numerical problems, then let's start. Otherwise you can go and visit our previous videos. So let's see the first problem. A particle is projected from the surface of the earth with a velocity of 20 meter per second at an angle of 30 degree. So it is given this is angle 30 degree and initial velocity is 20 meter per second. Now this angle is from horizontal as shown in figure. A wall of height 3 meter is given here at a distance of 10 meter. Okay, from the point of projection, find the out whether the particle hit the wall or not. So we have to find that if this particle will go like this, then it will hit wall here, or it will cross the wall, or it will fall before the wall. So let's find out. We have another problem, but let's first solve this first problem. We will move this downward so that we can have some space. Then let's solve this. See, the v naught is given 20 meter per second. So we can find the horizontal and vertical component of this 20 meter per second. It will be 20 cos theta, theta is 30 degree, and it will be 20 sine 30 degree, 20 sine theta, which will be 20 sine 30. So we can see Vx, velocity in x direction, or horizontal component, 20 cos 30, which will be equal to cos 30 is root 3 by 2. So 20 into root 3 by 2, which will be equal to, you can calculate from the calculator, 17.32 meter per second. So this is the horizontal velocity in this direction, horizontal direction. And what will be the vertical velocity? Vy, which is equal to 20 sine theta, or 20 sine 30, which will be equal to 20 into sine 30 is 1 by 2, which will be equal to 10 meter per second. Okay. I hope you understand up to here. Now, say this distance is 10 meter. So we will calculate how much time this particle will take to hit this wall, to travel up to 10 meter. So you can see that in horizontal direction, what we have, equation S is equal to ut plus half at square. Here S is the total displacement, u is initial velocity, t is time taken, a is acceleration in that direction, and t is time taken. If we see in horizontal direction, then we can see Sx is equal to ux into t plus half ax into t square. X means in horizontal direction, because our axis is like this, x-axis and y-axis. So you can see that in horizontal direction there is no acceleration. In vertical direction we have an acceleration downward, which is g, acceleration due to gravity, but in horizontal direction there is no acceleration. So this term will be 0. So this total term will become 0. So we will have Sx is equal to ux into t. So Sx is 10 meter. In horizontal direction we have to travel 10 meter to reach the wall. So 10 is equal to ux is also given, we have calculated it, 17.32 into t. So time taken to reach the wall in horizontal direction will be 10 by 17.32. If you calculate this, you will get 10 divided by 17.32 will be 0.577 second. Now we will see at this time 0.577 second in vertical direction what is happening. This ball is at what height? At 0.577 second. If this is lower than this wall, from 0 to 3 meter, it will hit the wall. If it is 0, then it will fall before the wall. And if this vertical displacement is more than 3 meter, means particle is somewhere here or here, which will cross the wall. So let's calculate. S y is equal to uy into t plus half ay into t square. Why we are just denoting that in vertical direction? So s in vertical direction, s we don't know, we have to find the displacement in vertical direction, which is equal to u initial velocity in vertical direction is 10 meter per second square. So 10 into time is 0.577 second minus. Why minus? Because we are moving upward but acceleration is downward, so it is negative. Half g is 10, you can see here g is given at 10 meter per second square into t square 0.577 square. So we will get, if you calculate this, then it will be 5.77 minus 5 into this 10 by 2 is 5. 0.577 square will be 0.33. This will become 5.77 minus 1.66. So in vertical direction, displacement will be Sy is equal to 5.77 minus 1.66 will be equal to 4.10 meter. So at that time, when ball will move the 10 meter here, then height is 4.1, which is more than this 3 meter. It means ball will move like this, or particle will move like this, and it will cross the wall, so it will not hit the wall. Find out whether the particle hits our wall or not. So answer will be not. I hope you understand this problem. Let's move to the next question. Let's fit it in the frame. An aircraft is moving horizontally with a speed of 50 meter per second at a height of 2 kilometer. So this is ground somewhere here. The aircraft is at 2 kilometer height. So this is, suppose, aircraft, this height is 2 kilometer, and it is moving with a velocity of 50 meter per second in horizontal direction. So velocity is 50 meter per second in horizontal direction. Then an object is dropped from the aircraft. So it is here a ball, suppose a ball or something is dropped from the aircraft. Acceleration due to gravity is g is given as, in vertical direction, 10 meter per second square. What is the time interval before the object hits the ground? So ball will be dropped from here, so it should move here. No, the flight is moving from with a speed of 50 meter per second in horizontal direction, so ball is also moving with the flight. So ball will fall down and move with 50 meters per second, so it will move like this in projectile motion. It will hit somewhere here, so we have to find the time taken for this ball to hit the ground, or object to hit the ground. So let's see. First of all, see, this unit is given in meter per second and this is given in kilometer. So we have to put the same unit. So we can put it in meter. So it will be 2 kilometer will be 2000 meter, because 1 kilometer is equal to 1000 meter. Now we have S is equal to ut plus half at square, where S is displacement, u is initial velocity, t is time, a is acceleration due to acceleration in any direction, and t is time. For vertical direction, if we write, then h, total movement in vertical direction h, which is 2000 meter, is equal to velocity in vertical direction, or we can write uy into t. This is minus half a will be g t square, minus because this is moving in downward direction. Sorry, it will be plus because ball is moving in downward direction and acceleration is also acting in downward direction. So it will be half gt square plus half gt square. G is acceleration due to gravity. So h is 2000 is equal to initial velocity in vertical direction is 0 because all the velocity is in horizontal direction. In vertical direction there is no velocity. 0 plus half into 10 into t square. So 2000 is equal to, will be 5 t square. So t square is 2000 divided by 5. So t square is 400. So t will be around 400, which will be equal to plus minus 20. So time cannot be minus, so it will be plus only. So ball will hit the ground after 20 seconds. So time interval before the object hits the ground is 20 seconds. So you have got your answer. If it was asked that what will be the distance moved by the ball before hitting the ground, then we could find it by r is equal to 50 meter per second into 20 seconds, which would be equal to 1000 meter. So I hope you understood this problem, and I hope you understand both the problems. So if you have any doubt, then you can ask in the comment section. And if you liked our video, then please share our channel and subscribe to our channel. And thanks for watching this video.